Okay, I'm back. So I am going to annotate this using Cami as we do this proof. Okay, so remember what we're going to be doing is we're going to have a statement and a reason. So generally, what I'm going to do and what you should do is kind of draw a line down the middle here, and so one side will be statements, one side will be reasons. So I'm going to write statement over here and reason over here. Okay, statement and reason. Okay, so first thing we're always going to do in a proof, the first statement you should always make should be a given. In this case, we really only have one given. Okay, AD is a perpendicular bisector. That's the only given. Okay, there'll be proofs where we may have 5 or 6 givens, and you'll have to start off with at least one of them. Okay, so I'm going to start off. Every statement and reason must be numbered. Okay, so this is going to be my first statement. I'm going to call it number 1, and I'm going to write AD is perpendicular bisector of BC. Okay, now my reason for that, is because it was given. All right, so that's going to be my first statement, and that's my reason, because again, remember the 5 different types of statements. One of them is a given statement. Okay, so we're able to write that as our reason. Okay, now the next thing I want to write, I want it to, I'm going to go by what I marked in the diagram. That's why I marked it. I marked it in the diagram so I would know what the next thing to say in the proof is. Okay, so I'm going to say 2. What was the next thing? Whoops. What was that all about? 2. Okay, the next thing that we said was BD is congruent, and you can use the congruent symbol when you handwrite these, but the congruent symbol is a pain in the neck in Cami, so I'm just going to write CONG. Okay, it's congruent to CD. Okay, and the reason for that I'm going to give here is going to be, I did it again, 2. All right, can I not do it the third time? I don't know why when I put a space in, it does this little jumping thing. It's annoying though. 2. All right, I won't put the dot. That'll help. All right. Anyway, the reason is definition of segment bisector. Okay, or I can write definition of perpendicular bisector. Either way, okay, because that's what was actually given, perpendicular bisector. But I'm bisecting the segment. That's why I can say that. Okay. Now, next statement. All right. Well, what was the next thing that I marked? I marked that angle. Okay, ADB. Make sure you name it properly. It's either ADB or BDA. Okay, make sure the vertex is the center letter. Is congruent to angle ADC. Okay, and I got to put a number in there, so I got to arrow back over there and put the number in. 3. Okay, and my reason is going to be 3. Again, but by perpendicular, my perpendicular bisector. Okay, a perpendicular bisector forms 2 congruent right angles. Okay, I'm saying it forms 2 congruent right angles. I said they're congruent over here. Okay, so I need to say they're not just right angles, but they're congruent right angles. I can say it all in one statement. Okay, not only are they right angles, but they're congruent right angles. Okay, so we're almost there. Okay, so we've got one side and we've got the other angle. Okay, and now number 4. Okay, the next thing that we said was AD is congruent to AD. Okay, and the reason that we're saying that 4 is going to be, we can just write the word reflexive, right? Reflexive postulate. Okay, and that's enough. Remember, postulate is one of the reasons that we can say a statement. All right, so this is a postulate. AD is congruent to itself. Now we've got everything we need. Okay, we've got two sides of one and the included angle. So I can now say, okay, that triangle, I gotta number it, 5, triangle ADB is congruent to triangle ADC. Okay, and the postulate that I used was SAS is congruent to SAS, and that's how you would write it. Only the the is congruent to would be this symbol. Okay, this symbol. Okay, now a couple of things. All right, so here I had, this is where I had the first side. Here's where I had my angle, and here's where I had my other side. Okay, I'm marking them here just so you can see that's how I got side, angle, side, congruent to side, angle, side. You don't have to mark them that way, okay? And we could have said these statements in any order, really. I needed the given first, but I could have done the reflexive next, and then I could have done the congruent angles, and then I could have done B is congruent to C. That they could have been in a different order. Okay, as long as the given was first, okay, because everything else is based on that given. All right, so that has to come first. Okay, and everything is supported by a reason. Okay, and all of the reasons and statements are numbered so that you can match one up with its corresponding statement or reason. All right, so that's it. That's your first triangle proof. Congratulations, you survived. All right, so let's continue. Let's scroll down to the next one and see what we got in this case. Again, the first thing you should always do is mark the diagram with what you're given. Okay, so this first one says, let's see, AE is congruent to BC. All right, so I'm going to mark that. All right, my pen. I'm going to mark AE is congruent to BC. Okay, angle E is congruent to angle C. Now be careful, they look like they're right angles, but you can't go by the appearance of the diagram. You can only go by what you're told. So don't say angle E and angle C are right angles, because that's not what this says. Okay, that says they're congruent to each other. That's really all you need. Don't say anything else. Okay, and then D is the midpoint of EC. Okay, so then that's going to mean that these two are similar, are congruent. Okay, so now again, we've got side, angle, side. Marking the diagram tells you exactly which of these methods, we've only done one so far, side, angle, side, but that's going to help you decide which method to use. Okay, so again, just like the other one, we're going to have to start off with a given. All right, so go to a text box here, and I'm going to, my first statement is going to be AE is congruent to BC. AE congruent to BC. Okay, and I'm going to put over here, that's going to be my given. Okay, and already that's already a side. Okay, all right, so my second, so now I can just move on. My second statement, what a pain in the neck. All right, so angle E is congruent to angle C. Again, that one is a given. All right, so these givens, it basically spotted us the first two parts that we needed. Okay, so this was my angle. Okay, now 3. D is the midpoint of EC. D is the midpoint of EC. Notice how I abbreviated that. You can feel free to abbreviate midpoint MP. Okay, I will know what you're talking about. Okay, and 3, well, that one's also given. That doesn't directly give us for the other side, though. We need another statement, okay? So in this case, I'm going to put 4. The next thing that I marked was that ED is congruent to CD, okay? Now, that is by definition of midpoint. By definition of midpoint, that splits that segment EC into 2 equal pieces. So I can say, by definition of midpoint, ED must be congruent to CD. Okay? And now I've got everything, because that was my other side. Okay? So I'm finished. I just have to state, I always have to state at the end, that prove statement should be my last statement of my proof. It's like the defense saying, we rest our case, or the prosecution says, we rest our case. All right, so 5, triangle ADE is congruent to triangle BDC. Okay, and again, this is how we're going to finish up with a reason. We're going to say SAS, side angle side, is congruent to side angle side. Okay? Okay, so now what I want you to do for homework is try the next 3. Okay, just a couple of notes. There's some weird looking things. These little things should really be above those letters. They should be like the segment symbol. Okay, so for some reason they got shifted over. Don't be confused by those. Okay, just here, make sure you pay attention to what is doing the bisecting and what is being bisected. Okay, it's because that's gonna matter. It's gonna determine what you say as your statement. Okay, that one should be pretty straightforward, hopefully. Okay, and then for number 3, QT and PS bisect each other. Okay, so what does that mean? Okay, for those 2 segments to bisect each other. Okay, and in this case, the included angle is going to be vertical angles. Okay, so just give you a little hint. Okay, these will be vertical angles in here, and that's how you're going to get your included angle. All right, so good luck. See what you can do to write these proofs, and I'll have you submit them on Google Classroom. All right, till next time. See you later.